Okay, I'm back. I just changed my shirt and put on this hat and started another video because actually it's just a couple minutes later from the other one. But I thought I'd change things up a little bit, giving you another view of my boyfriend's house, his dining room, just another angle. Hope you guys are doing well, and I'm going to get started with the next chapter. I'm going to go ahead and share my screen for the next objective here. And that objective is objective 4. And in this objective, we're going to talk about randomly assigned and repeated measures designs. And we'll talk about some of the special problems and solutions associated with the repeated measures design. So let's go on and look first at the randomly assigned design. For some reason, not going. Okay, so we call this, sometimes we call this independent groups design, sometimes we call it randomly assigned design, but basically the difference there with that in the repeated measures design is that each participant is only going to get one level of the independent variable. And that's assigned randomly. So that's what we've been talking about in the past. So I had a student who did an experiment. I'm going to use it as an example of rap versus country lyrics. So what he did is he took a set of lyrics. So it was kind of like written out in almost like a poetry sort of form, a rhyming set of lyrics. And he labeled it as a song. And the song was either labeled rap or country, but it was the same exact set of lyrics. Everything was perfectly controlled. The only difference between the two sets of lyrics was one was labeled a country song, but it was the same lyrics, and the other was labeled a rap song, but it was again the same lyrics. So what he did is he had people rate various aspects of the song. How aggressive was the song? How good was the song? How much you liked the song, et cetera, et cetera, et cetera. You know, how much passion was there in the song or whatever. And all they read was the same set of lyrics, but again, labeled differently. Now, he randomly assigned them to groups. So that means that with every individual who's going to participate in the experiment, he did the equivalent of flipping a coin, and it was like heads, you get the country version, and tails, you get the rap version, or vice versa. It doesn't really matter. But the idea is that everybody had an equal chance of either getting the rap or the country version of the song. So then that was what we call a randomly assigned design or an independent groups design, meaning that the group that got the country version never ever saw the rap version, and the group that got the rap version never ever saw the country version at all. We don't want any mixing in between those, because the minute they would find out, oh, this is the, you know, I got the rap version, but somebody else got the country version, right? Then they would know the purpose of the experiment, and all of that would be for naught, because the purpose of the experiment was obviously to see whether people thought differently about a song because it was labeled either rap or country. Okay, not by the lyrics. Okay, so a different way of doing this would be the repeated measures design. And it's when, instead of having those two groups that are different from each other, where you have a different group of people here getting rap, different people here getting country, what you have is one group, and they get both conditions. So we wouldn't be able to do this in that kind of experiment with the rap versus country, because it would really mess up our results, because people would know what it was about and the purpose of it, and then they would start acting weird. But we can do this in a lot of different cases. So for example, you probably heard maybe somewhere about the Pepsi challenge. And that was something that Pepsi as a cola did as a marketing campaign. And it was the equivalent of a repeated measures design. So what they did is they took a group of people and they had them taste two different sodas. They had them taste Pepsi and Coke, but it was in a disguised form. So everything was blind. There were no labels on it or anything like that. Two identical cups, one Pepsi, one Coke. And what they did then is they had them rate each cola. Now notice, we could do this as we could randomly assign people to just have Pepsi or just have Coke, but instead they did it differently. They did it in repeated measures design, meaning that every single person tasted Pepsi, then they rated the Pepsi, and then every single person tasted Coke, and then they rated the Coke. So each participant gets each level of the independent variable. Okay. So for example, why don't you try this example on your own? You can do this by pausing the video and trying it, and then you can start it again and I'll go over it. So what this is designing a randomly assigned and repeated measures experiment. And what we want to do is try it with this example. So this would be the effects of choice on exercise adherence. So our participants are women who enroll in an exercise class, and the independent variable is the choice of music. So they get to choose their own songs in the first level collectively. So together they talk about it and they get a list of songs, or they don't get to choose their own songs. And the idea is, how much do people adhere to it if they have their own music? Are they better? Do they stick with the class more if they get to choose their own songs? So how would we do that? The question is, how would we do that as a repeated measures design, and how would we do it as a randomly assigned design? So let's try it first as a randomly assigned independent groups design. We're going to have 2 different groups. So what we're going to do is we're going to take each participant, we're going to randomly assign them to either get in the choice of music group or in the no choice or the pre-assigned music group. And the group here is totally different from the group here because they're randomly assigned to one or the other. They do not experience both. In the second case, in the repeated measures design, we could do the same thing, except what we do is we take the same group of participants, and for 1 week, they get to choose their own songs, and then we see whether they come back the next week. And then a few weeks later, they get another session where they have pre-assigned songs. But it's the same group of people that get both conditions of the independent variable, as opposed to the 2 different groups of people. And then we look at how many sessions they attend to see whether that, in fact, was effective to be able to choose their own music as the point of the story. Okay. So why would you use a repeated measures design? Well, for one thing, there are many fewer participants needed for it. You don't need all those participants because, look, if you're trying to get 20 people per group, then you only need 20 people because they're going to do both groups, right? They're going to get the choice of music and then they're going to get the pre-assigned music. Whereas if you do the independent groups design, then you're going to need 40 people. Because you need 20 here that get the pre-assigned, and you need 20 here that get the choice of music. So you need fewer participants. It's very sensitive to finding results because you don't have much variation in between groups because it's basically the same people. So everything is controlled. They're the same age, you know, in both conditions. They're the same race in both conditions. There's all of this built-in control to the repeated measures design, which is nice. But there are some disadvantages too. For example, people can guess the hypothesis, and this is a really big disadvantage because when people guess the hypothesis, they start acting in accordance to how they expect they should act. So if they guess that it's about music choice, then they start to act in accordance with that, and they might start going more just because they think that that's what you want them to do. Another possibility is what's called a carryover effect. And that's where the effect of one condition bleeds into the other condition. So let's go back to the Pepsi challenge. You have a Pepsi and a Coke in front of you. And you're going to taste the Pepsi and then rate it. And then you're going to taste the Coke and then you're going to rate it. The problem there is that once you taste the Pepsi, right, the Pepsi taste might be kind of lingering in your mouth still when you taste the Coke. So the Pepsi, in fact, the condition there might bleed into the Coke condition and make you rate the Coke condition slightly differently. So how we control for that is we make ample time in between conditions. So if you have a time in between a condition, you start with one condition and then you allow enough time in there to make sure that that condition, the effects of that condition have kind of petered out before you start the next condition. So you wouldn't want to taste the Pepsi and then taste the Coke right away. You would want to make sure there's 5-10 minutes in there, eat a cracker, whatever. Okay, the other possibility of a problem is what's called an order effect. And that's when the order of the conditions will influence the results. So let's say you start this experiment and you're very, very thirsty, you know, or nobody's had anything for a while. So everybody starts with the Pepsi, and we drink the Pepsi and we go, oh my God, the Pepsi's so good. Oh, it tastes so good. It's just so nice to have some fizzy liquid in your mouth, right? And so that tastes delicious. Then you rate it, and then you taste the Coke, but now you've already had the Pepsi, and because the Pepsi came first, it might have been perceived as better because you were thirsty at that point. The Coke, now you're not as thirsty, so we have an order problem there where the first is preferred because you were thirsty there. And so how we take care of that problem is that we take half of the subjects, and they will taste in the order of Pepsi and then Coke. And then the other half of the subjects will taste in the order of Coke, then Pepsi. So what you've done is you've evened out the order effect. There still may be an order effect for sure. But what you've done is you've ameliorated the problems associated with that order effect, because Pepsi has an advantage for being first, but then Coke also has the same advantage for being first just as many times. And so you've taken care of that problem. You've evened it out, you've controlled. Okay, another problem is called a fatigue effect or a practice effect. So for example, let me think, what you would do, let's say you had a worksheet. You were going to test the effects of a worksheet versus the effects of a video for learning some math problem, right? And you decided to do a repeated measures design there. What you would do is you would give people presumably the video, and then you would see how they do on the math test, and then you would give them the worksheet, and then you would see how they do on the math test. One of the problems you have in this case is called a practice effect. They're going to get better on that math test just because they're taking it for the second time, not necessarily because of that second condition. And so you have that issue. One of the things that you can do for that issue is the same thing we did with the order effect in general, which is divide up the order of the conditions. So in one group, you know, you take half of people anyway, and you start with the video lesson, and then you go to the worksheet lesson. And in the other half, you start with the worksheet lesson, and then you move to the video lesson. And so we always have to control for these order effects. And it's not really a disadvantage to use a repeated measures design as long as you control for those order effects. That said, you can't do it for every design. Like I was talking about with the rap versus country music lyrics design, that you can't do because they guess the purpose of the experiment, and it just doesn't make sense to do it for certain designs like that. But for the Pepsi challenge, it's great, it's fine. Okay, here are some ways of controlling for order effects. So there's two ways of controlling for order effects. Now, when you only have two conditions, it's very, very easy because you just split the group in half. And if your conditions are Pepsi and Coke, excuse me, then you do one group with Pepsi, then Coke, and then you do the other group does Coke first, then Pepsi second. That's very easy if you only have two conditions. But a lot of times with an independent variable, we'll have three or more conditions. And then it's not a bad idea to use one of these, either counterbalancing or what we call the Latin square. In counterbalancing, what we do is just pull randomly a condition for each participant in order of conditions for each participant. So let's say that you have three conditions. We're going to name those A, B, and C. Okay, so this would be the equivalent of like Pepsi, Coke, and RC Cola or something like that in that particular example. And what we would do is pull a random order of conditions. So it might be B, C, A is the random group of those three that we pulled. And that first participant is going to get that. For the second participant, we pull another random order, which may be A, C, B or something like that, okay? In the Latin square, it's a little bit more systematic way of deciding what orders. What we do is we make sure that each condition appears in the first, the second, and the third order an equal number of times. So you can see here we have three different orders in the Latin square for the ABC conditions. We have ABC, and then all we've done there is move the A to the end, and now we have BCA, and then we have CAB. So you can see that C occurs in the first order, in the second order, and in the third in this group of 30. And A also occurs in first, second, and third, and B also occurs in first, second, and third. And because each of those positions is evened out, we have no effective order there. Okay, we're going to do the very last objective in this video, and then that's going to complete this video. We're going to describe the use of a statistical test called the analysis of variance. And like other statistical tests in this class, I'm not expecting you to be able to do the statistic, rather, because you'll learn that in the statistics course, but more I want you to see how it is used to be able to analyze the data for an experiment, or how it's applied. So I'm going to talk about it a little bit more conceptually. But the test, the statistical test, is called the analysis of variance. Now, we've talked about variance before, and variance, it just comes from the word vary or variability. So what we're going to do is we're going to analyze the variability. And so it's a very common statistical test that examines the results from an experiment. So when we do an experiment like this, what we can do is examine the results using the ANOVA. And what it's going to do is it's going to test whether the differences between groups are due to the manipulation of the independent variable or just by chance. Okay, so let's say we have, let's go back to the rap lyrics versus the country lyrics. Remember, we have exactly the same lyrics on two pieces of paper. They're just labeled rap lyrics or they're labeled country lyrics. And now we ask people how much they like the song. Or let's say how aggressive, the original experiment that did this asked how aggressive the lyrics were. Now, let's say that subjects think that the lyrics are more aggressive when it's labeled a rap song than when it's labeled a country song. So they see the lyrics as more aggressive in the case of a rap song. What this test is doing is saying, did that just happen by chance? Or was it really because the song was labeled a rap song versus a country song? So we're looking at the effects of chance versus the effects of the independent variable. And to do that, we calculate a statistics that is called F, that is referred to as F. And what the statistic does is it looks at the variance between the groups. So again, variance is just variability, how much the groups vary. It looks at the variance in between groups, in between the group that looked at the rap lyrics versus the group that looked at the country lyrics. Is there a big difference in how those groups rated aggressiveness of the lyrics? And then it divides that by the within groups variance. So within groups variance is just what you think it is. Within a single group, there's a certain amount of variance, right? Some people rated it as, remember, this is all within one group. So these are people that looked at it as the rap lyrics, right? Everybody that looked at it as the rap lyrics. Some rated it as highly aggressive, and some rated it as not so aggressive, even within that group. And those that were in the country group, same. We get some rating them as more aggressive and some rating the lyrics as less aggressive. So we have the between groups difference, which is the difference between these two groups, and then we also have differences within a group. And what the F statistic does is it looks at the differences between groups, and then it looks at the differences within a group, and it factors out by dividing the within groups variance out of the between groups variance. So we have the between groups variance that is going to be divided by the within groups variance. And as you can see there, that the bigger the F statistic, if the F statistic comes out very large, the more we are likely to say that this result is significant, because it means that the variance between groups was huge compared to the variance within groups. And that's what we want to see if indeed our label of country versus rap made a difference. We want this difference to be much bigger than the difference within a single group. And so that's what all that statistic does. Okay. All right. Here are some exercises, or at least this is one exercise that you can do by stopping the video now and trying out this exercise. And then when you start the video again, I'll be explaining the exercise. So go ahead and pause and try this. So this is an exercise in some basic experimental design. Here's the exercise. An institution starts a training program for employees and wants to evaluate the effectiveness of that program. So what they do is they test one group of employees after completing the program. So you just have one group here, and you're going to test them. You're going to give them this program, and then you're going to test them after the program. So now, let's say the program, for example, is on cultural competence. Lots of different companies are trying these cultural competence programs. So we take all our employees and we go, now you guys got to do a cultural competence program, and we train them all in cultural competence, how to deal with other cultures and everything. And then it turns out, so then we do a test on how well they deal with other cultures. And then if the employee's performance on the test is good, we conclude that the program is a success. Now, I want you to ask yourself, what is wrong with this design? So we know that our employees' performance is good. They're culturally competent. But can we be sure that it was indeed that training that caused them to have greater cultural competence? And in this case, I would have to answer no, we cannot, because we don't know what they were before the program. We have no pretest, right? So they could have already been culturally competent before the program even started, right? We also don't have a control group at all. So we have no idea what somebody would do if they hadn't gotten the program at all. And so we could change this into a good design. So I want you to think about how you might do, for example, repeated measures design here to change this into a good design. And in that case, what you would probably do is take a group of participants, you'd randomly assign them to either get the program or get some other program, which would be like a placebo control, right? Some unrelated program, some program in gardening or something like that, right? And then you would test their cultural competence. Afterwards, you could use the ANOVA statistic to look at the difference between them. This group should be higher on cultural competence than the group that got the gardening program, right? And so that would be a much better design. And that would be a one-way experimental design. Okay, well, this concludes objectives 4 and 5. Remember that you do have my cell phone number, 573-303-4734. Feel free to call me or text me anytime. We can also do Zoom meetings if you need some extra help. I know that this isn't easy, guys. It's not easy on me either, but we're going to make it through this semester, and I hope you're staying happy and healthy.